I'm talking with Nell Watson, founder of Pollyco, a company that enables 3D scanning of the body from any device. You're also an engineering technologist, an inspirational speaker, and a futurist thinker. So very pleased to make your acquaintance. The first thing I wanted to talk to you just straight off the bat is the Singularity University in the States. You're a member of the faculty there.
Yes.
Singularity, it's run by NASA, it's over in Silicon Valley, it seems like a really exciting place to be.
Absolutely, yes. Singularity U isn't affiliated with NASA, right. But it is based at the NASA's research park at Moffett Field, just off NASA Ames Research Center. Okay. Absolutely, Singularity University is well, it's really the brainchild of two wonderful people, Raymond Kurzweil and Peter Diamandis. And each of them has one big, amazing idea. And for Raymond, it's about the singularity. It's about how the accelerating changing of technology, the accelerating rate of change of technology is leading to accelerating returns. Basically, faster machines, more information, more empowerment. And Peter's big idea is about abundance. So Peter Diamandis looks at the fact that the Washington Monument was coated at the tip in aluminium. And that's because at the time it was built, aluminium was the most expensive material on the planet. And yet only about 10 years later, they had developed the electrolytic process to extract aluminium from bauxite ore. Before that, bauxite ore had just been chucked out as if it was junk. And so many times throughout history, we have found ways to do so much more with less, and things that we thought were worthless are actually extremely valuable. And at Singularity University, those two ideas coincide. And so the Singularity University's mission is to apply exponential growth in technology for creating abundance within the world. So that's applying technology to help solve problems such as poverty, health issues, food, water, energy, etc.
Very good. The work that you're doing specifically in the faculty, what have you been involved in yourself?
Well, I was a student actually back in 2013. I joined the graduate summer program. They take about 80 people from around the world each year, from 50, 60 different countries typically. And some of them are engineers, nerds like me. Others are designers, architects, health professionals, counselors, artists, a whole range of different people. And where you have different cultures meeting for the first time, you often get a huge spurt of innovation. And that's exactly what happens during the graduate summer program. It's about 50% learning about the latest in technology and being able to spot disrupting influences within technology. And the other 50% is about applying that. So that's creating a new venture in order to help apply this technology in improving the world.
Wow, and you're originally from Northern Ireland. Were there many other Northern Irish members of the graduate program at that time?
I was the only one from Northern Ireland, but there have been plenty from Ireland in general and UK in general. And I think on some of the other programs, I think that there have been some lucky folks.
Just I was looking at your company and what it does, and also your personal website, where you've put up, say, by graphs, your knowledge of language, the countries you've visited, your outputs, your interests, and it's all it's produced as a diagram. It's metrics. It just strikes me as an individual, you're fascinated by metrics and measurement.
I am. I love numbers. I love science. I love drilling down into things. And I love being able to express that in a visual way that's easy to understand. That's one of the things that gives me the most pleasure, is taking something that seems very complex and making it simple, and then sharing that with other people.
Pollyco, a company that enables 3D scanning of the body from any device. That company was set up it's within the past sort of 3-4 years, is it? Yeah. Right. So it's a fairly new company. It's a new That would be a new application of the technology, I suppose. It's a patented technology that you guys have developed.
That's right. That's right. It's taken several years to perfect it. The technology was actually developed quite early on, but there's quite a gap between technology and a product. And so it's taken time in order to examine different potential markets and to create a product around the technology itself.
I can imagine through just locally there's a movement called European Connected Health Centres based here. Personalisation within health is a major issue with the 3D scanning application, with something that's just as portable as a mobile phone. You're able potentially to monitor clients or users or patients.
One of the strongest goals of the project now is to help connect people with healthcare providers all around the world and to provide elements of remote telemedicine. We've seen a great surge in interest in the quantified self, this idea of life logging, of tracking what your body is doing over time. And there's lots of kind of like graphs of people checking their movement during the day, or I mean, all of that data is interesting. But once you begin to put it against holistic 3D information, that's when you can really start to make sense of what does that data mean, right? When you tally the graphs to something tangible, like a 3D object. Or when you're able to create a future version of yourself, which is your body, but it is edited to have a slightly different body mass, and you can set that as a target. And then you can 3D print that data, and you can have it on your desk as a little memento to get out and do a run now and then. And I know that it's powerfully motivational because I use the technology myself in testing it, of course, as I would, and during the development. And well, I lost about 15 kilos in quite a short period of time because I could see where I wanted to get to, and I knew that it was achievable.
It strikes me as an interesting concept, the way you would take the 3D view of a body, but it will impact upon the mind. So there is a holistic approach to it. So your goals as a person are directly impacted by something you visually see, how you're progressing over time. So it has a positive and beneficial effect on your outlook or your personality or how positive you are as a human being, I suppose.
Absolutely. And one of the interesting things is because it's 3D data, we can animate it. And that means we can have your body, potentially with your texture on it if you want, doing push-ups and working out. And that's such a fantastic way of priming the subconscious, right? It's like having this virtual you that works out, and it tells you to go and do the same.
Where do you imagine mass customization and personalization of this type, where do you think that technology will take us over the next decade or two?
We are increasingly digitizing our world. We have found ways of capturing our environment, capturing elements of ourselves, working with them in a computer environment, and then spitting them out again, like in 3D printing, or in augmented reality, imposing the virtual into the physical realm. I believe we're seeing an increasing blend or blurring of physical and virtual realities. And technologies like 3D sensors on tablet phones are going to be a very empowering tool for that. For example, I suppose many people are now familiar with the Microsoft Kinect, which is a 3D or depth sensor for the Xbox. And we're now seeing similar technologies coming out for tablets, which enable a tablet or a smartphone to have the same kind of capability. And this means that you can map an entire room in just a couple of minutes, just by slowly scanning it with one of these sensors. And of course, due to the exponential growth in technology, these sensors are becoming extremely powerful very quickly. They're getting smaller, cheaper, much more capable. What this means is that we are going to be increasingly digitizing everything around us all of the time. And technologies such as autonomous cars and drones, we think of them as just a transportation mechanism, but they're also a sensor. They all have these LiDARs and similar kinds of 3D sensors around them. So instead of the Street View car coming down your neighborhood twice a year, it's going to be every car on every street, which is going to be scanning and collecting all of this data. Now, we've seen now that all of the data in human history collected up to the year 2000 is now created every 8 to 10 minutes.
Wow.
That is a phenomenal rate in the amount of data that we have at our disposal. And of course, we're just going to see that increase ever more over the next couple of decades.
That's a massive capture of data, and well, we're generating lots of it. It's what you divine from it. How do you take some utility from it? What can you take from the data that's useful on the other side of it? I mean, that's a question that I keep trying to get my head around.
Right.
If we're generating so much, what do we do with it? What next? What do we do with it?
It's possible to drown in data, right? You've got so much, you can't make sense of it, and it ends up being seemingly useless. Thankfully, we have a whole range of new emerging machine learning algorithms which are now able to interpret that data and create new analytics. And in fact, the two go hand in hand. Having all of this big data, as they call it, is enabling machine learning algorithms to learn at a faster rate because you've got more stuff to train it on. And of course, these machine learning algorithms are in turn generating more data, and so it's a sort of self-reinforcing process.
And for example, machine learning, if a machine is reading data and drawing conclusions or is extrapolating some kind of meaning from it, could you see that being applied to the legal system or to the medical system, where you could have a contract dispute settled automatically by a machine? Is that feasible, or what do you think?
Traditionally, machine learning has been what's called structured learning. It's been based around teaching the machine, sort of guiding its hand and saying, this is a tree, this is a box, this is a car. But now we're finding new techniques called unstructured learning, which is kind of like how a toddler or a young child, a young human, also learns about the world by playing, by experiencing, by touching, putting things in their mouth as they do, rather than sitting in a classroom and being instructed. And these unstructured mechanisms for learning have vast potential. New technologies like deep learning, for example, are the first of a new wave of unstructured machine learning that enables programs to learn how our world works and to generate new assumptions. Most of the things we do as humans are based around very basic assumptions, very basic heuristics, as they call them. That gravity is stable, that a cup will break if you drop it. These are all very simple things. And in fact, social interaction, like a conversation, is also based around assumptions, and it has its own protocols. Traditionally, machines have been very bad at this. They're great at calculation, they're great at graphs and math, but they're terrible at understanding fundamental assumptions. That is changing. And what this means is that machines are now able to engage with us on a similar level to how we engage with each other. And this is unlocking a whole new wave of machine intelligence.
Yeah, it is fascinating. I think is it a Turing test on robotics and machines? It's where you test their ability to mimic human intelligence and human behavior.
Behavior is not intelligence, and a Turing test cannot actually discern whether an agent has intelligence or not. It might be intelligent but cannot emulate a human, or it might be dumb as a brick but has all of these behavioral heuristics,
And do you think that there will be, and this is where are we getting closer to AI, and is that where that overlaps into AI? Just explain
Yes.
what AI is, I suppose, is starting point.
Well, AI is artificial intelligence, and there's many different spectrums, I suppose, of intelligence, of an artificial nature. And traditional AI, as we think of it, such as characters in video games, perhaps, or agents that can figure out what you're trying to ask for on the telephone. Those are defined as narrow AI. But broad AI, or sometimes called strong AI, is what technology is working to over the next 10, 20, 30 years. So that's more artificial generalized intelligence. And we're at a crossing over point. We're kind of in the middle between the two.
So I suppose, playing devil's advocate, this might be the reason why Stephen Hawking recently said I think he said flatly, AI is the greatest threat to humankind. I think it was as bold a statement as that, and it made me stop and think, Stephen Hawking, whenever he is saying that, perhaps there's cause to pause and think, is this something we should do? It's the Jurassic Park thing, because we could do it, it doesn't necessarily mean that we should. What do you think?
Well, I think in many ways it's unavoidable. I don't think that there is a way to avoid the emergence of strong artificial intelligence in the coming years and decades. However, my impressions are mixed, but more optimistic, I think. A lot of people are concerned about killer robots, right?
Yeah, HAL, and I don't think you should do that, Dave, and all of that,
Skynet.
all that good stuff. Yeah.
Yeah.
Yep.
I don't think that is going to be so much of a problem, because in our society we have ways of stopping amoral or sociopathic behavior. And it works fairly well after the fact. If there's been a murder, we normally detect it and we can figure out usually what happened and who did it. However, what we cannot predict and what we cannot respond to easily is super morality. So, there's something called Kohlberg's stages of moral development, and it's roughly 6 stages that this psychologist Kohlberg reckoned that we go through in life as we develop a greater moral sense. And from the very basic, don't do something because you'll get in trouble, to don't do something because it's against the law or it's against religious belief, towards more social contract or universal ethics. And what if there's more than 6 levels, but as humans find it difficult to reach them? Now, we can hardly imagine what the world would look like to someone with an IQ of 200 or 250. The same way, we can scarcely imagine what it would be like to have a super moral sense, an ability to look at the world in a much more objective and unbiased way. We are humans with our assumptions, and our assumptions give us biases. Machines may not have those biases. And so how will a machine respond to humans and the way that we treat animals, for example? Those are really interesting questions.
Yeah, absolutely. I'm thinking from the humanity as a species, we have 4 or 5 million years of evolution and development behind us to get up to this point, whereas we have machines now that are evolving by days, weeks, what we can achieve over millennia. It is just there's clearly it's disjointed. How do you control that? I would you want to, but we have to get our head around these things, because we are going to be left behind. I wonder, is that part of the problem, or in persuading people that this is a positive thing for us to explore further?
I recognize a lot of people are terrified by accelerating change and by the increasing looming cyborgization of people as they become slightly more joined to machines over time. And there are a lot of concerns, and a lot of people feel like maybe we lose something sacred as we become closer to being machines. And then there are other perspectives, that we are already machines made out of meat, and that we should not hold our bodies to be entirely sacred, that we can augment ourselves if we wish. And why should we suffer the human condition or make others suffer if they do not wish to? And I wonder if there's going to be a kind of a cultural discussion I don't want to say culture war, but it's going to be a lot of interesting perspectives in the mix of people that demand the ability to not to age, or demand the ability to increase their intelligence, and other people try and hold them back. And I think that's probably going to lead to significant conflict over the coming decades.
Well, I think there's, noting from some of your talks previously, you're able to marry some of these these are big philosophical issues that predate machines. You know, this is stuff that maybe Aristotle or Socrates, all this sort of stuff that's been happening in classical Greece, these are in some ways age-old questions that we're still wrestling with. The technology has slightly changed, but it's fascinating to see the continuum of thought from over 2,500, 3,000, 4,000 years. We're still having these discussions, but just in a slightly different context.
Absolutely. And I think it's funny that we still have so much to learn from philosophers like Aristotle, despite, you know, almost 3,000 years having passed. One thing that excites me is that if we can teach machines to have better assumptions about us, about humans, we can begin to make them understand ethics, as I mentioned, supermorality. And if we teach machines better about ethics and values, there is a potential for machines to teach us philosophy, new philosophy that we otherwise might not be able to achieve by ourselves. I believe that in the coming decades, machines will help teach us how we ought to be living our lives, and will help take us to the next level, away from the limitations of the human condition as it is at the moment.
Wow, that's, I mean, mind-blowing stuff. The very thought that you can, these are in the areas, these are emotions and sensitivities and your prejudices and your biases and all of the things that make us the interesting things that we are as a species, I guess. Within
15 to 20 years, we're going to be able to simulate an entire human brain. We will have the computational capacity to do that. But even more, we'll be able to map the human brain with tiny little nanocomputers that float in our bloodstream. So as we already have the technology to make a tiny little semiconductor, which is kind of like a silicon chip, and we can actually engineer viruses to create them. So we have genetically engineered viruses that make silicon chips on a tiny atomic scale. We can create wires out of, there are certain bacteriums that eat electrons. Almost every creature eats sugar and turns it into energy, electrical energy. We are electrical beings. But certain bacteria and viruses eat electrons, and other viruses can produce electricity using piezoelectric effects. So it's kind of like the clicky fire lighter you light a gas oven with. We can use those same effects to generate power. Further technologies like DNA origami offer a kind of like a 3D printing for DNA. And you can actually make very interesting tiny little structures out of that, such as logic gates, and or XOR. When you put that mix together, you have everything that's needed to create a computer. And so you can have a liquid computer that exists inside your bloodstream, kind of like a co-pilot that is within you. And these little components can be moved around the body using electromagnetic processes. And what this means is that your entire neural net of your brain can be scanned and saved. And that means that you can be uploaded into a computer, potentially. Or your biological neural net can be augmented using artificial means. Now today we install apps on our phone, right? We get a new functionality. In the future, 20, 25 years from now, we will install AUGs instead, augmentations. And what that means is that if you wish to play piano like Debussy, you will be able to download the capability to extend your consciousness to have that function.
I've seen The Matrix. I think that's exciting. I think as well I mean, potentially the cure for cancer is something that's then potentially within our lifetimes then?
It may already exist. For example, the nanobots that I mentioned, these nanomachines, which are built out of DNA origami, they're now in trials for doing a complete cure for leukemia. These things can just swim around in the bloodstream, killing off the bad cells, kind of like trapping them in a little tiny little mouth. And this is not science fiction. You know, we think, oh, nanobots and the Borg and all this stuff. This is fact.
Well, thanks very much indeed, Nell. That has been a fascinating and mind-blowing discussion. Thank you so much for your time. Thank you.
So delighted to be here. Thank you.